Hello everyone. As we move distal in the upper limb, this presentation will cover the forearm. In this slide we have here on the left side the whole upper limb with the pectoral girdle, the arm, and now we're going to be covering the forearm, which is made by two bones, the radius and the ulna. The radius is always going to be lateral and the ulna is going to be medial in an anatomical position. Remember, every time we talk about the orientation of the bones, we're always considering it in anatomical position. The way that I remember that the radius is lateral is that it has the thumb, right? Because the thumb is always going to be lateral. Therefore, the thumb is like the antenna for the radial. So radius is going to be lateral. Therefore, the ulna is going to be medial. Now the image here on the right, again, is a little bit hard to see all the details, but one thing that we can see is that between the radius and the ulna, there's going to be this membrane over here that's called the interosseous membrane, which makes sense as inter means between. So it's between the bones and it's a membrane. And this interosseous membrane is made of fibrous tissue, as you can see, and it will have this oblique orientation from the radius to the ulna. This membrane is going to be important because it will maintain the interosseous space between the radius and the ulna when the forearm is rotating, and we will talk about the rotation of the forearm coming up. And it also actively transfers the forces from the radius to the ulna as it rotates. With regards to the rest of the bone features, I think it's best that we look at them in the next few slides. Let's start with the ulna. For me to be able to identify the ulna by itself, the first thing that I look for is on the proximal end. It's going to have this shape like a U, therefore U for ulna. So this will make it easy for us to differentiate the ulna from the other bones. On a posterior view, as we can see here on this first image, there's going to be this big bump over here posteriorly, which is called the olecranon or the olecranon process. And also on the distal end, we're going to have the styloid process, and this would be the head of the ulna. On the anterior view, we can see a little bit the head of the ulna, which is distal. And also on the proximal end, we can see a few more bone features. So up here we can see a little bit of the olecranon, but it's better seen in a posterior view. This U part of the ulna will be what we call the trochlear notch, which can better be seen over here on the medial view. And then there's this little thing that sticks out, which is called the coronoid process, located anteriorly. Another bone feature that we can see on this anterior view is this flat part over here, which is called the radial notch. I will talk more about the radial notch when we get to the radial ulnar joint, but for now, you just need to know that this flat area over here is the radial notch. One thing that we should mention is that the head of the radius is the only head that's going to be distal on a long bone. All other heads will be proximal, meaning that they will be further up, closer to the torso. Here we have a magnified view of the proximal end of the ulna. Again, on a posterior view, we can clearly see the olecranon or the olecranon process. This part over here that forms the U will be the trochlear notch, and this bump over here that sticks out will be the coronoid process, and here is the radial notch. The way that I remember these three bone features on the proximal end of the ulna is that I think about OTC, which means over-the-counter medication, or for the ulna, it will be the olecranon, the trochlear notch, and the coronoid process, so OTC. On a magnified view of the distal end, the only two bone features that we need to know about the ulna are the styloid process, which is similar to the styloid process in the skull. Remember, I told you it would look like a little stylus pen. Therefore, it's sort of the same idea, but for me here, this looks like a a high heel of a shoe, especially this view right over here. So this would be your styloid process, and the other bone feature would be the head of the ulna, which, like I said, is the only one that's distal compared to other bones. Now let's talk about the radius. The radius is going to have a head that's going to be proximal like every other bone except for the ulna, which is distal. Under the head, we're going to have the neck, which is this part right over here. Then we're going to have this part that sticks out, which is called the radial tuberosity, so a rough projection on the radius. On the distal end, we're also going to have a styloid process, which is this part right over here that's sticking out. And then on the medial side of the radius, there's going to be a flat part that's called the ulna notch. So remember that on the ulna, you had the radial notch, which was proximal. And now on the radius, we have an ulnar notch, which is distal. And we will see as we move along on the slides how all these bone features will articulate with each other. Again, on a magnified view of the proximal end of the radius, this is the head, this is the neck, and this would be your radial tuberosity. Same thing on the other side, the head, the neck, and the radial tuberosity, anterior view, posterior view. On a magnified view of the distal end, this is an anterior view, this is the posterior view. We can clearly see the styloid process over here on both sides. And here, this flat part would be your ulnar notch. Now that we know the bone features of the humerus and the bone features of the radius and the ulna, we can see how they will articulate to form the elbow joint. Remember that on the humerus, we had a condyle, which was the smooth articulating surface that was divided into two parts. We had what we call the capitulum, and then we had what we call the trochlea. So the capitulum will articulate with the head of the radius. And the way that you can remember this, remember I said that the radius reminds me of radial, and the capitulum is going to capture the radial signal. So capitulum articulates with the head of the radius. And the trochlea is going to articulate with the trochlear notch of the ulna. And it's going to form like a hinge. That's why you're able to move your elbow back and forth because of this hinge joint here from the trochlear notch with the trochlea. Trochlear notch of the ulna with the trochlea of the humerus. And these bone features we can clearly see on the anterior view. On the posterior view, what you will see is that the olecranon fossa, which was that big depression that we saw on the humerus in the posterior view, will accommodate the olecranon of the ulna. On these views, we will be able to see a little bit better this articulation between the humerus and the radius and the ulna. Let's start right over here in this middle image. This is your condyle, which is a smooth, round, articulating surface. I know that this is the medial side because this is your medial epicondyle. Notice how the condyle is going to be divided into two parts right over here. The one that's lateral is what we call the capitulum. The one that's medial is what we call the trochlea. This is the radius and this is the ulna. The radial head will articulate with the capitulum and the trochlea will articulate with the trochlear notch, which is the U part of the ulna on the medial side. And on a posterior view, we can clearly see that the only thing that's entering into the olecranon fossa is the olecranon of the ulna, which can also be called the olecranon process. The radius is not going to be articulating with the olecranon fossa. Now, one thing that we should introduce here is the movements that will occur at the elbow joint. So there are only two movements that will occur at the elbow joint. When our upper limb is in an anatomical position, meaning that it's hanging on the sides straight like this, This means that the elbow joint is going to be extended. Now, when you bring the forearm up, it means that you're flexing. So you're going to be decreasing the angle at the elbow joint. When you decrease the angle at the elbow joint, what do you think will happen to the fossa? This one here on the medial side is going to be the coronoid fossa, and the one on the lateral side is going to be the radial fossa. When you bring these two bones up in this direction, then the coronoid process, which is this bump right over here, will go inside of the coronoid fossa, and the rim of the radial head will go inside of the radial fossa. So now let's put all these terms together and you will see that it will make sense. The capitulum, which is the part of the trochlea on the lateral side, will articulate with the head of the radius. The trochlea, which is on the medial side, will articulate with the trochlear notch of the ulna. The coronoid fossa on the medial side of the humerus will articulate with the coronoid process of the ulna. The radial fossa of the humerus on the lateral side will articulate with the rim of the radial head. And posteriorly, the olecranon process of the ulna will articulate with the olecranon fossa of the humerus. And this articulation of the olecranon fossa with the olecranon process, it only occurs when the forearm is extended or your elbow is extended. When your elbow is flexed, then the olecranon actually comes out of the fossa. If you guys right now, if you flex your elbow, you're going to feel this big bump on the outside. So this is the olecranon coming out of the olecranon fossa. When you extend, if you put your hand right at the elbow, you're going to see that it's actually very smooth and straight, meaning that the olecranon process is inside of the olecranon fossa. And here, I'm not sure how to play this video, but if you guys get your PowerPoint and you look at the video of the flexion will be in this direction and the extension will be moving it straight, you will see exactly how the radius or the radial head will go into the radial fossa on this lateral view as the elbow flexes. And as this happens, the olecranon process is actually coming out of the olecranon fossa. So make sure that you play this video using your PowerPoint. Here we have what we call the radial ulnar joint, which is a joint between the radius and the ulna, so it makes sense. These two bones, they will articulate not only on the proximal end, but also on the distal end. On the left side, we have the proximal end, and this image is actually a great image to see the U of the ulna, therefore the trochlear notch. And laterally, you can see the radial notch of the ulna. The head of the radius will be the one that will articulate with the radial notch of the ulna. On the opposite side, we can see the ulnar head right over here of the ulna, and this is your ulnar notch of the radius. So this means that the ulnar head will articulate with the ulnar notch of the radius at the distal end. So this can be a little bit confusing. So when I say the bone feature, I always like to say the name of the bone as well. Remember that a bone cannot articulate with itself. It can only articulate with another bone. Therefore, this is the radial notch of the ulna, and this is the ulnar notch of the radius. And this radial ulnar joint, it will perform these two movements, pronation and supination. When you are in an anatomical position, you're actually in supination mode, meaning that your palm of your hand is facing up. But when you rotate and you put your thumb now on the medial side, this will be what we call pronation. So try to play your video on your PowerPoint as well, because these are our little animations. So this means that the radius will actually come to the medial side. And then when you move the radius back to the anatomical position, you're doing supination. So this occurs between the radial ulnar joint, not only on the proximal end, but also on the distal end.